Hey guys, this is Adba and today we'll be going over the metabolism of chylomicrons and cholesterol. So let's dive right in. First of all, let's discuss chylomicrons. So what are chylomicrons? Chylomicrons are lipoproteins. Lipoproteins themselves are classified into four types: chylomicrons, VLDLs, LDLs, and HDLs. And as you can see from this arrow, that the density increases as we go down. Okay, so chylomicrons are basically transporters of dietary triglycerides from the intestine to the peripheral tissues. These chylomicrons are then rich in triglycerides, low in cholesterol, and also contain apoproteins and phospholipids. You've probably seen this bar graph multiple times by now, but it is actually a very good representation of the contents of the chylomicrons and their proportions, and these proportions relative to the other lipoproteins. So as you can see, it has the highest proportion of triglycerides out of all of them because obviously it is the transporter of triglycerides in the body. Moving on to the metabolism, chylomicrons are synthesized in the intestinal mucosa. Apoproteins A and B48, these are very important, please remember them. These are synthesized on the ribosomes of the rough endoplasmic reticulum in the mucosal cells. These apoproteins enter the lumen of the endoplasmic reticulum where they combine with triglycerides to form the nascent chylomicrons. Nascent meaning new. Okay, and now I have highlighted here the contents of the nascent chylomicrons, which are apoprotein A, B48, cholesterol, and triglycerides. The nascent chylomicrons are transferred to the Golgi apparatus and released into the lacteals. When in circulation, the nascent chylomicrons receive apoproteins C and E from the HDLs, and these are converted now into active chylomicrons. Now, these active chylomicrons contain all of the contents of the previous nascent chylomicrons along with apoproteins C and E. Their functions you'll see ahead. Okay, so lipoprotein lipase is a very important enzyme which you all have to remember, and it is present in all of the most of the extrahepatic tissues. And at the enzyme receptor sites, apoprotein C2 and phospholipids in the chylomicrons activate lipoprotein lipase. Conversely, apoprotein A2 and C3 act as inhibitors for lipoprotein lipase. Lipoprotein lipase then hydrolyzes triglycerides in the chylomicrons into free fatty acids and glycerol. The free fatty acids are taken up by the tissues for their cellular activities, and glycerol goes into the liver via circulation. After we've lost about 90 to 95% of all of the triglycerides from our chylomicrons, the apoproteins A and C are transferred from the chylomicrons to the HDL, and the chylomicron is now converted to a chylomicron remnant, which enters the liver via apoprotein E specific receptors, which where they are now broken down. So as you can see, first of all, we had the nascent chylomicrons, which turned into active chylomicrons, and then finally the chylomicron remnants. This is a table I took from Kaplan, and it's actually a pretty good table. It shows you all of the lipoproteins you need to know, and the apoproteins which they contain, their functions, and also the specific functions of the apoproteins in those particular lipoproteins. So this is a table that you should know. You can take a screenshot or whatever, write it down. Okay, so now we can move on to the metabolism of cholesterol. What is cholesterol? Cholesterol is a steroidal lipid, and the choline cholesterol represents bile, while the sterol part represents the steroidal alcohols, that is itself a subclass of steroids. Majority of cholesterol is synthesized in the liver, about 50%. The rest is in the intestines, skin, and adrenals. Moving on to the synthesis. The synthesis of cholesterol, I know, can seem a bit daunting, but it is actually pretty easy, and it's broken down into just 5 steps, which we will cover now. Okay, so the first step is the formation of HMG-CoA 6 carbon from acetyl-CoA 2 carbon, and this is facilitated by the enzyme thiolase. The second step is the formation of mevalonate 6 carbon from HMG-CoA by the enzyme HMG-CoA reductase. This is a very important enzyme, and this is a very important step. And that's why this is known as the rate limiting step, because it controls the rate of synthesis of cholesterol. The third step is the production of the isoprenoid unit, 5 carbon. The fourth is the synthesis of squalene, 30 carbon. And the fifth is the conversion of squalene to cholesterol, 27 carbon. An intermediate product in the conversion of squalene to cholesterol is dinesterol, 30 carbon. And this occurs right here in the middle. A nice little mnemonic that I came up with was, hey, Mev is so cute. And this will help you remember this whole synthesis process. The H in A stands for HMG-CoA. MEV obviously stands for mevalonate. I stands for the isoprenoid unit. The S in SO stands for squalene. C in Q stands for cholesterol. And one thing I used to then remember was that squalene was 30 carbon. And a trick that I used was that mevalonate is 6 carbon and isoprenoid is 5. So 6 multiplied by 5 gives you 30. And that's pretty much what I did. Okay, so finally, we have to know that there are certain things which can inhibit the synthesis of cholesterol. And there are basically three pathways by which we can inhibit the synthesis. The first is by comparative inhibition, and this is by statins, which are anti-hyperlipidemic drugs, which you'll probably do in pharma. These inhibit HMG-CoA reductase. Remove this inhibitor part. The second is feedback inhibition, where HMG-CoA reductase is inhibited by mevalonate and cholesterol. These are the products of cholesterol synthesis themselves, and they basically act as a feedback and inhibit the synthesis, so there is not an excess production of cholesterol in the body, which can be harmful. Thirdly is the covalent modification via hormones, specifically the hormone glucagon. Glucagon inhibits the synthesis of cholesterol, and conversely, you should know that insulin increases cholesterol synthesis because insulin usually has the opposite effect of glucagon. And that pretty much covers everything. One thing that I would like for you to know is that this lecture shouldn't be used as a substitute for all of your other lectures in your books. You should go through those as well. What I would recommend is that you use your books and supplement those with the slides so that you have all of your bases covered. So yeah, that's it. Thank you for listening, and I hope we meet again in the next lecture.